Hello, my name is Steve Gaynor. I am the owner of a consulting company called Pivot Corp that helps building product manufacturers in the facade space through internal product management initiatives like new product entry, channel strategies, technical topics like navigating testing and compliance, as well as much more. I'm here today to talk to you about Local Law 126, which is the 2022 New York City Construction Code, and its effect on exterior cladding assemblies. As we discuss this today, there are going to be a lot of confusing and complex code language topics. If you do want to reach out to me after the presentation, please feel free to do so. I just ask that you are patient with my response. All right, let's get started. So today we're going to start with some ground rules and a refresher on a few different things, including definitions and NFPA 285. Then we're going to get into a brief history on the code section, really to give us context for why Local Law 126 is a topic today and why some of these topics within Local Law 126 are changed in the way they are. Then we'll talk about what Local Law 126 means in terms of exterior cavity details. And finally, we'll finish up with a few other important points related to the fire blocking and some other language for facades in 126. All right, so ground rules, and these are very important. Rule number one, building code logic doesn't exist. When we talk about the building code, it is not about just science and logic as a result of the science behind it and performance. Building codes are made just as much by the discussion in the room and the politics behind that discussion as it is about the science behind some of the requirements. So, no judgment on that. That's what it is. Rule number one is building code logic doesn't exist. Rule number two is that this is a no judgment zone. Like I said in the first one, we're talking about just what it is today and where we are today, how we got here, and maybe all of the negative and positive feelings you might have about why and how we got here is not important. Building codes always have conflicts, gaps, and areas of confusion, especially when they are new, and even more especially when they are something that is a significant change in the building code. There's just no way to get around it. Rule number three, building code language does not equal project compliance, right? We can talk about the language all day long. It's just as much about how it's enforced, right? How the AHJ is going to enforce it and how all the inspectors are going to enforce it throughout the process. So as we talk about language, just because it's the language is in there is not necessarily how the building code will be enforced. And obviously, the most important ground rule is always going to be the disclaimer. If you're going to be using any of the topics we talk about today for a specific project or specific product, please consult an expert as well as your local building department about how it applies to your specific situation. All right, let's get into that refresher. So we're going to start with definition review, and the reason why we're going to do that is because if you have read this code language, and you'll see later on in the code language that we show that a variety of terms are used in different parts of the language, often for the same assembly or the same parts of the assembly. Also, there's instances where the same term is used for different parts of the assembly. So it's good for us to review and just get into a mindset where we can say, okay, we can avoid the confusion of a different term being used and go to a general category or part of the assembly when we hear those different terms. So we start with exterior cladding. Exterior cladding might also be called exterior wall covering, or architectural trim. The exterior cavity, that's that cavity between the exterior cladding and the next layer. That's either the water resistant barrier or the exterior insulation. That is known as exterior cavity, airspace, concealed space, or just simply the space. You'll see that often in the code too. Cladding attachment system, sometimes called substructure, attachment system, framing or framing system, or just components. For exterior insulation, you might hear me talk about rigid insulation or the CI layer. And then the water-resistant barrier is mostly referred to as water-resistant barrier. You might see air barrier or water control layer. Water control layer is a very common one also. Together, they're also known as the exterior assembly, facade system, or exterior wall covering. And so you'll see both exterior wall covering being used as the cladding or as the entire assembly with all of the components in it. Let's get into a quick review of NFPA 285. Probably if you're listening to this, you already have some familiarity with NFPA 285. NFPA 285 is a multi-story fire test that determines whether the cladding or exterior assembly, including the cladding all the way back to the sheathing, contributes to the propagation of flame and heat, either up the wall to the next level or laterally to the next room. The NFPA 285 test is conducted on a two-story assembly. That assembly is slabs of concrete, as you see here. This is a nice section view. It has a bottom floor and a top floor, a bottom room and a top room. The exterior assembly is applied on the outside of that of those two slabs, and there is a hole that simulates a window in the bottom floor. That bottom floor has a burner in it to simulate flashover conditions, and then an exterior burner is applied to that to enhance that. During this test, there are many parameters. The main ones that you'll see are that there's no flame in the second room, and that the flame and heat don't go above 10 feet. Oh, I'm sorry. The flame does not go above 10 feet or 5 feet from the window during the entirety of the test, and the heat does not exceed 1,000 degrees, both 10 feet above the window and 5 feet from the center of the window. So that's both the flame and heat, 10 feet above the window and 5 feet from the center of the window. That's where it's measured. It's important to remember that we are bringing a 10-foot by 10-foot box in terms of the area that's measured for this test, and we'll call back to that later. But the reason why NFPA 285 is also important to review is because the test itself was created based on a notion that the fire doesn't care what it burns, right? So the building code is always going to be behind innovation in terms of materials, in terms of applications. And so as new materials come into the code, NFPA 285 and the requirements around that are often used to say, well, there is a requirement for materials that are on the building, and those materials perform in a certain way. So materials that are allowed in certain building types or construction types, they perform a certain way. So if those allowed materials perform in a certain way, as long as we're applying materials that perform either just like that allowed material or better, those materials should be allowed on the building because the fire doesn't care what it burns, right? And so that's an important thing to keep in mind as we go through the language here. NFPA 285 as a test itself, whether it's being run as a project test with the project team and architect, or whether it's being run by the manufacturer, which is most often being run, it takes about 4 to 6 months at the very quickest to put together one of these tests. It ends up being somewhere around $40,000 to $80,000 all in, and you're looking at about a week of build time and a day of testing in order to get this done. So it's not a quick endeavor, and in order to accommodate changes like this, the industry has to go through a bit of a lag period in order to catch up and actually get these tests run. Now let's get into the history of the New York City building codes. So we're going to start with the 1938 code. Obviously, that's the first code in New York City that applies specifically to New York City. Throughout the years, you'd have local laws that would amend small parts of it here and there. But the next major revision was in 1968. So you'd have 1938 to 1968. That's 30 years. And you'd have the same thing in terms of small revisions after that. Then in the year 2000, you had Mayor Bloomberg sign an order saying that the New York City Building Code should align with the IBC. Then the 2008 New York City Building Code, or New York City Construction Code, was the first one to align with the IBC, and that aligned with the International Building Code, or IBC, version 2003. After that, you had the 2014 construction codes for New York City, and that aligned with the International Building Code 2009. And then you had the 2022 construction codes, which are the ones coming out later this year, or effective to be enforced later this year uh, uh, on November 7th, 2022. Those 2022 construction codes are aligned with the IBC language for 2015. One of the reasons we're talking today is that the IBC 2009 to IBC 2015, so that's two code cycles. There was a International Building Code IBC 2012 that came out in between there, but those years had some significant changes in terms of facade fire requirements, or language around facade fire requirements, that sort of set the seeds for the language we're going to talk about today. So in 2017, the technical committee was formed to review the IBC 2015 language for inclusion or alignment with the 2022 construction code in New York City. There's a lot of discussion about a lot of different topics. We're going to be talking a lot about fire blocking today. That fire blocking topic, for the most part, was introduced and pushed by the New York City Fire Department and some others. And that's where I think a lot of the debate revolved around, which ultimately led to some irreconcilable differences that ultimately led to this committee going into mediation for those topics. So in 2019, that mediation began, and in December 2020, the determination letter was released. That is more or less the basis of the final code language. So a big question is, why now? Why are we arguing over these fire blocking topics, or these topics in general, at this point in the game? Well, I think that the landscape was ripe for it. The 2019 to 2015, 2009 to 2015 IBC changes that we referenced before um, really led to a bit of contention on a few sides, and it was because they took a couple steps forward and then took a step back. In my opinion, rightly so, but I think that it led to a lot of confusion and some tension. So those few steps forward had to do with NFPA 285. And in 2012, the IBC decided to adopt language that basically included any wall with a water-resistant barrier to have to be tested to the NFPA 285 standard. Now that meant any wall, regardless of whether you had combustible cladding or a non-combustible material over the weather-resistant barrier, or whether the entire assembly, really didn't expose the weather-resistant barrier to the fire at all. And so there was a lot of pushback within the industry. As you can imagine, we talked about how much time that test takes. Labs would get significantly backed up, and you would have a difficult time even getting to a test in order to comply. Some major jurisdictions decided to not adopt this language into their local building codes. Some modified the language to water it down. Ultimately, because of the pushback and I think some of the review of the science behind it, in 2015, the ICC decided to adopt exceptions to that language that tempered it to a more reasonable point where the weather resistant barrier was something that was looked at as a trigger based on its own characteristics. And that is sort of the two steps forward, one step back that we're talking about today, and the environment of confusion that set up some of the discussions. Also, in this time period, we had the tragedy in London at Grenfell Towers, and appropriately so, the people that are charged with protecting us, right, from a fire standpoint, from making sure that our buildings are safe and that the inhabitants within the buildings are safe, uh, looked at what happened in London and said, how do we make sure that this can't happen here, or how do we look at what we're doing and change it to make sure that that we're avoiding this in the future. And so, that led to, I think, a little more of an emotional debate around some of these topics, and fire blocking really became the center of a lot of these emotional debates. What you see here on your screen is from the official Grenfell report. I think it's important to clear up the fact that Grenfell did have fire blocks on it, in as much as we would be requiring it in New York City. In my opinion, fire blocking is not the lesson to learn from Grenfell, right? There were materials on Grenfell that should not have been on Grenfell Towers, and that is one of the lessons. But there are other great lessons to learn, including that increased focus on evaluation of compliance documents and increased scrutiny of on-site compliance, which New York City does do a good job at starting to address. Now let's get into the fire blocking sections of the code over the years. So we're going to start with the fire blocking section that's going to take up most of today, but we're going to start with it in the 2009 IBC, go through the changes in the IBC, and then go through the changes that New York City adopted. So in 2009, this is the section 717.2.6. It was called architectural trim. And basically it said that fire blocking is required in 100 square foot compartments, wherever you have a concealed space, for architectural trim. Right? That's what the language says. It wasn't necessarily being enforced like this. Uh, Rule number 3 is that code language does not equal compliance, right? And enforcement was a little different. You can imagine the NFPA 285 tested assemblies showed real performance in fire. And so if you had an NFPA 285 tested assembly, often building officials would say, we're not going to change the geometry of that assembly. It shows that it performs the way we want it to perform. And so if you have an NFPA 285 assembly, you do not need to worry about fire blocking regardless of what the other language says. Put it up the way that it's been tested in NFPA 285, and we're okay with it. Now, this was not stated anywhere in the code, but a majority of the building officials out there were taking this position, and that's where you get to some of the language we'll talk about later. The other thing that you had in the IBC language 2009 and before was this language in 1406.2.4. Now, I am not sophisticated enough to read this in the way that it was enforced, but this was often explained to me and used in a way that said that up to basically 40 feet, if you had a concealed space that was less than 1 5/8 inch, it did not need fire blocking. Now, in 2012, the that section was changed. So 717.2.6 became 718.2.6. They changed the architectural trim heading to exterior wall coverings just to reduce some confusion. And you'll see here, exception number 3 was added. So it said what and codified what the building officials were using for compliance already. It says fire blocking shall not be required where the exterior wall covering has been tested in accordance with and complies with the acceptance criteria of NFPA 285. The exterior wall covering shall be installed and tested in accordance with NFPA 285. If you have an NFPA 285 tested assembly and that passes, use that tested assembly the way it passes, and fire blocking is not required. Then that section in 1406.2.3 was also modified to basically confirm that if you have an NFPA 285 assembly, regardless of the cavity depth, you do not need fire blocking. Then you had IBC 2015, and the reason why we're showing this is because IBC 2015 is the language that the new New York City Building Code is based on. So IBC 2015 is the same as IBC 2012 in this regard, and that's what we'll pick up the language. So 2014 New York City Building Code. Now let's take a step into New York City, take that same section, show that that same section in 2014 matches the 2009 IBC, right? All right, now we're at Local Law 126, which is the 2022 New York City Building Code. So Local Law 126 is not just about fire blocking. It's about many other issues in the facade, but also the plumbing code, mechanical code, fuel gas code, and some other items. What we're going to talk about, obviously, is the building code changes and specifically about the fire blocking within the exterior cavity. Okay, Local Law 126 is about 3,000 pages. There are a few hundred pages addressing the facade assembly fire requirements, and we're going to go over the basis of those, which then sort of spider out into all the different places in the code that they affect. Importantly, the process is to amend the 2014 Construction Code for New York City rather than to take the IBC language and amend that. And you'll see as we go along, if you're used to reading code, where those changes affect the code. So first, let's take another look at that 2014 Construction Code for New York City. And that specific section about architectural trim or the fire blocking within the architectural trim, it matches the 2009 IBC for those 100 square foot compartments with a maximum length of 20 feet and doesn't have the exception for NFPA 285. So the biggest change here is you take that 2014 section and the number changes from 718 or 717 to 718. Same thing happened in the code. That's just because they added some sections in there that doesn't affect the code itself. But you see that fire blocking section goes from this 10 or 12 lines, maybe a little more, to everything you see on the second or the right-hand side of the page here. Now let's get into another part of the 2014 code that changed significantly, and that's NFPA 285 requirements in Chapter 14. So essentially, Chapter 14 and Chapter 26 talked about NFPA 285 for the 2014 Construction Code. You see it says MCM shall be tested in accordance with. It was essentially used for anything that was combustible. Now you take those sections and you have that 1403.5, which was added to 2012, except New York City decided to add additional language to that, which made it what you see on the second half of your page. And we'll talk about that here and there throughout the discussion today. So, getting into the fire blocking section for local law 126 or the New York City or 2022 Construction Code. You see that first part is not much different than the other requirements, requiring that 100 square foot compartment. That's essentially a 10 foot by 10 foot compartment, both vertically and horizontally. So you're putting up fire blocking in squares or rectangles in 100 square foot compartments. The largest largest span you can go is 20 feet. So that would mean, let's say you have slabs at every 10 feet. You're going to go 2 slabs by 5 feet, and that would be your 20-foot compartment, or in any other sort of geometry. But again, 100 square foot compartments, both vertically and horizontally. So those fire blocks are going vertically and horizontally. Important here, you see the added language for the purpose of this section: fenestration products, flashing, and the flashing of fenestration products and water-resistant barrier flashing and accessories at other locations shall not be considered combustible construction. Importantly, it does not say water-resistant barriers. It says the water-resistant barriers flashing, and that will come up several times. So we take that 100 square foot compartment fire blocking requirement that applies to everything, right? And we add exceptions to that. And this is the same thing that happens in the IBC. We have that requirement. We have exceptions underneath it where it doesn't apply. The first thing you'll notice is that they chose not to accept the NFPA 285 exception that the IBC accepted, the one that codifies the way that building officials were doing it prior to this, where they said if you have an NFPA 285 and you've passed it in a certain geometry, don't add fire blocking to that. We will accept it as is because that shows the performance. New York City said it chose not to accept that, so you'll see that's not in one of the exceptions here. The first exception, 2.1, is that basically aluminum plate material. So it's aluminum cladding with thickness of 0.5 millimeters or more, non-combustible framing, no plastic or foam plastic insulation, and you don't need to do fire blocking. Then you have the second exception, same thing with steel cladding, 0.4 millimeters thick of steel, non-combustible framing, no plastic or foam plastic insulation. So now we look at the next exception, and that's 2.3. What New York City has done here is they have removed the previous exception, 2.3, which was other approved non-combustible materials. This is also what's in the IBC. They've removed that, and they've added a new section that specifies exactly which non-combustibles in which thicknesses qualify for this exception. That means if you are using other non-combustible materials in your wall covering, right? So that's your wall covering, your framing, your insulation, if you're using all non-combustible materials there, but they are not listed specifically in the exception, then you do need fire blocking in that non-combustible assembly as long as you're using a combustible water-resistant barrier. So the question that comes up is, does it really apply to other non-combustibles if the water-resistant barrier is the only combustible in the assembly? And the short answer is yes. I know it doesn't make a lot of sense because non-combustibles are non-combustibles. However, we go back to rule number 1. The building code logic doesn't exist. And so we have to look at the language in here and accept it for what it is and ask ourselves, how do we comply with this? So to justify that yes answer, we look at 718, the first section of 718, basically saying this chapter applies to both combustible and non-combustible concealed locations. And then we look at the fire blocking language in 718.2.6, and we see that the exception or the allowances that said that certain things, including the water-resistant barrier flashing, don't qualify as a trigger. And then we look at that language and we say, okay, where does that language come from? We take that and we compare it to Chapter 14, where you have the NFPA 285 requirement for water-resistant barriers, and we see that that language comes directly from the NFPA 285 requirement in Chapter 14. However, what New York City chose not to do is include the exceptions that are in that NFPA 285 section that say certain water-resistant barriers, depending on their performance, do not constitute a trigger, and it gives you the performance criteria that you need to meet. Again, New York City chose not to put that into this fire blocking section, and therefore, if you're using other non-combustibles and a water-resistant barrier that is combustible, you still need to have fire blocking per the language here. When I met with the Department of Buildings, they confirmed that that their reading of this is the same as my reading of it here. So we will take this and consider it as we go forward in terms of our compliance discussion. So let's look at the non-combustible materials that are part of the exceptions here that they said specifically these materials are going to be are not going to require fire blocking. And so they have it listed as brick, concrete, stone, terracotta, stucco, or steel cladding in accordance in thicknesses according to table 1405.2, right? So that's a table in chapter 14. We'll look at that in a second. But it's those materials in those specific thicknesses that are listed, as long as they have non-combustible framing, no plastic or foam plastic insulation, and a weather-resistive barrier is the only combustible component. So let's look at chapter 1405.2, that table. And if we go down those specific materials that are listed in the exception, we see that brick is essentially you're looking at any brick that's 2.625 inches or more. Concrete is not listed here. Natural stone is listed at 2 inches or more. Cast artificial stone is 1.5 inches or more. Terracotta is 1 inch or more. Stucco essentially 5/8 of an inch or more, and steel at 0.0149 inches. I think that's the 0.4 millimeter conversion. Again, these are the listed materials in these thicknesses. If you have these materials as your cladding and you have all non-combustible construction other than the weather barrier, you do not need to use fire blocking. So let's revisit those other non-combustibles. Like we said, if you're using any other non-combustibles that are not listed in that previous exception, then you will need to have fire blocking in your cavity per the language. You see on the left-hand side of your screen a list of non-combustible examples, and I'm sure there's more that we can add there. But essentially, with these and other non-combustibles that aren't listed, as long as you're using a combustible water-resistant barrier, then you're going to need to have 100 square foot fire blocking compartments, right? So that's essentially a 10 by 10. You could go up to 20 feet in one direction, so that would be 20 by 5 or anything in between there. But importantly, it is compartments, so it is both vertically and horizontally. You will need to have fire blocking in your compartment for these types of materials. That finishes the non-combustible exception. Now you get into exception for combustible materials, plastics, HPL, MCMs, and you have those listed in exception number 3. Exception number 3 says that exterior wall coverings containing plastics, metal composite material, or high pressure laminates shall comply with section 718.2.6.1. That means they don't need to comply with the main section here for the 100 square foot compartments. They do need to comply with this listed section 718.2.6.1. What does 718.2.6.1 say? Essentially, it says that you need fire blocking for plastics, MCM, and HPL around all wall openings, at every slab edge for a minimum height in terms of fire blocking of 8 inches thick. And then when the occupancy changes, whether that's vertically or horizontally across your elevation. There's one more thing in that slab edge. It says that maximum intervals of 20 feet. So if you don't have a slab for 20 feet, that means that you would need to put a horizontal fire blocking in there at every 20 feet or every slab, whichever one is less. Importantly, this does mean that you do not need the vertical parts of those compartments, right? So if you have the non-combustible materials with your weather barrier, you need those vertical parts that are added to your fire blocking to create those compartments. If you're using combustible materials, you do not need those. What you need is around all wall openings, so doors, windows, penetrations, etc., at every slab for a minimum of 8 inches in height and when the occupancy changes. For foam plastic insulation, you have essentially similar requirements saying you need fire blocking wherever you're using foam plastics around wall openings, windows, doors, penetrations, etc., at every slab edge, and that fire blocking has to be a thickness of 8 inches at every slab edge, and then when the occupancy changes both vertically and horizontally. Very importantly, if you're using foam plastic insulation, that insulation needs to be interrupted. So the fire blocking needs to go all the way from the back of your cladding to the sheathing or the weather-resistant barrier, and the foam plastic needs to stop, and then it would continue after the fire barrier again, or fire block again. So that's something that needs to be noted if you're using foam plastic insulation. The foam plastics fire blocking section has its own exceptions, and they are important exceptions. The first one is that exterior walls on one-story buildings do not need to have fire blocking as long as your foam plastic meets certain requirements listed here. This second one is a big one. It says if you're using foam plastic and your exterior veneer is concrete, masonry veneer, or EIFS on concrete backup walls up to 75 feet, you're not required to have fire blocking at each floor line. There's still a question of whether fire blocking is required for openings and so on, but it's a big exception for using foam plastic behind these materials up to 75 feet. And the final exception is on detached 1- and 2-story dwellings. Fire blocking of foam plastic insulation shall not be required at every floor in detached 1- and 2-story family dwellings of type 5 construction that don't exceed that 40-foot height that you've seen before. So the question still remains, do you need around openings and so on? But again, a very important exception. So what does this mean for other combustible materials that are on the outside of buildings? Well, essentially what they've done, again, the same thing they did with that exception for non-combustibles in the fire blocking section. New York City chose to specifically list the materials that you can perform an NFPA 285 on to comply. And those materials are EIFS, MCM, HPL, and FRP. All other materials don't qualify under this section, so you can perform your NFPA 285 test to comply with those materials as long as you're using those materials. If you're using any other combustible material, then you have to go to the combustible materials section, and essentially what that says is that other combustible materials must follow different rules. They cannot qualify using NFPA 285. They now have these following limitations. So what are the limitations? You've been using other combustible materials as your exterior wall covering. They are limited to a maximum height of 40 feet and 10% of each story on an elevation. They're also not allowed on walls that use CLT or SCL as their structural members. So now that we've reviewed the language, let's get into what that means in terms of how we're going to have to detail our buildings, our wall coverings, the rain screen assembly beneath that to accommodate these fire blocks. What you see here is a fairly rudimentary four-story building. The yellow lines are your non-combustible fire blocking. I've put them at each slab, which I'm assuming is about 12 feet, and then 8.5 feet from vertical fire block to vertical fire block, and that creates our 100 square foot compartments. You may note that I am using the fire blocking requirements for non-combustible materials, but we can basically extrapolate this for what we need to do for combustible materials as well. So the first thing that we'll have to do is we'll have to put our cladding material in between those horizontal fire blocks if we want to maintain any sort of ventilation and drainage to get the most out of our high performance walls that use ventilation and drainage, so your rain screen walls and your ventilated facade cladding materials or your cavity walls. So let's put those panels up between the horizontal fire blocks. And then because we are putting those panels up between the horizontal fire blocks, and we want to trap as little moisture as possible against the back of our cladding and inside of our assembly, we're probably going to want to put thin strips of our wall covering or exterior cladding over those horizontal fire blocks, specifically as thin as your cladding material will allow you to go. And so we're going to put those up as well. Now, this is going to be essentially the aesthetic that is going to be the most simple way to accommodate the fire blocking requirements. It might be the only way to do this with rain screen assemblies, but I'm sure that there's qualified designers out there who come up with some interesting designs. So the question is, what do we do around these spots, right? Because this is where we have that horizontal fire blocking. And so let's take a section view of that spot. Essentially what you see here on the right-hand side is you see a concrete slab, you see a stud wall both above and below that concrete slab, and then you see some sort of insulation outboard of that stud wall and your exterior cladding. For this, where I'm not showing the attachment system or your water resistant barrier in any part of the assembly, although you can obviously figure out where those would go. The important part here is that we've put that 8 inches of fire blocking. This might be 4 inches of fire blocking. One of the things that is not defined is exactly how thick the fire blocking needs to be for all other areas. The slab for combustible materials is the only one that dictates 8 inches, so it might be 4 inches. Whatever that is, it's still going all the way from your wall to the back of your cladding to make sure that we are closing off that exterior cavity. So as you can imagine, if you've been doing this for a little while, that's going to cause some problems for ventilation and drainage, which is exactly why you're creating that exterior cavity. You're going to get water coming down the top of that and stopping at whatever that fire blocking is. Maybe that fire blocking doesn't absorb water, but it's definitely going to direct water one way or another, and you're going to get more water against your wall and other places that you wouldn't want to have that. So let's look at the bottom there, and the bottom has the same issue with airflow. The airflow issue is a little easier to address. Well, below the fire blocking, behind the fire blocking, obviously there's going to be or within the fire blocking, obviously there's going to be no airflow regardless. But below the fire blocking, you can put that joint there and still maintain some airflow behind your system as long as the bottom has a joint also. For that water, obviously we don't want to put metal flashing all the way through your exterior insulation continuously around the building at every slab and all of your openings. But if we do it right on the face of the insulation, you are probably going to have problems with getting water in places where you don't want it and places where it's not easy to dry out. So essentially, you have to put something going all the way through the insulation so that you can manage this water, right? And the obvious answer to that would be some sort of flashing, usually metal. And so now you have this flashing, yes, directing water out so that you're not getting it accumulating at your fire block. That flashing has to go all the way from the basically flush the face of your exterior wall covering, and then back all the way to your water resistant barrier. And in that case, you are creating a continuous thermal bridge all the way again through that wall assembly, but also all around the building every time you have fire blocking. That carries with it some other challenges as we talk about energy performance and things like local law 97 and how we comply with that, because that's about the actual energy we're using in a building rather than a prescriptive way to build walls. And as we put this into the wall assembly, put these continuous thermal bridges all the way around the building at every opening, wherever we need fire blocking, we are obviously decreasing the performance of that wall, and we're going to need to deal with these sort of competing requirements in terms of exterior wall performance. You might put a membrane flashing back there that goes over your wall system, out over the exterior insulation. But the question on the membrane is really what are we putting it over, and how is it integrating with the rest of the system, and how durable is it if we put a membrane that's attaching to several different materials before it gets out of the system. So those were the options that essentially cover the approved ways to fire block. One of the things you might be thinking is, why don't we just put a piece of steel angle going all the way through the wall assembly, essentially coming to the face of the cladding and breaking up the compartments, but widening those joints, and now you have your airflow, you have your drainage, and you have your fire blocking. That steel, for the most part, is going to do well to reduce the flames that come up the wall assembly or the exterior cavity. Well, steel is not one of the approved fire blocking materials in the 2022 New York City Construction Code, and there's some good reasons for that, but also we need some solutions. So, in speaking with the Department of Buildings, these sort of things definitely can be reviewed, and we'll talk about some of the language they put in there for that on specific projects. But as of now, with the language that we see, this would not be an acceptable way to create fire blocking, although it would be a sufficient way to create that drainage and ventilation we need for your high performance walls. Probably still have your thermal control issues. Another question is, can we use activated fire blocks, right? That would be a really great solution in order to maintain the airflow and drainage that are designed into these high performance systems like rain screen, ventilated facade materials or assemblies. Activated fire blocks like intumescence are something that are around and now are specifically made for these exterior cavity areas. I myself have tested several NFPA 285 tests with these sort of activated fire blocks, and what they do is obviously, when you put them in, they are a small strip here, and that they allow for the ventilation and drainage that you would want in a high performance assembly. And then as you have a fire, these things heat up to a certain temperature and expand and char over and create a fire block specifically for the fire event. These are not currently addressed as part of the New York City Building Code. They are not in the approved materials list. However, the building department has assured me that they are looking into these things, and hopefully we'll get some guidance on this. They have shared that we would need to as designers and manufacturers and engineers come up with a package that would prove to them that this would be a sufficient solution. So what are those fire blocking materials? Well, we have them listed here. You see the fire blocking materials almost mirror the same materials that are in the IBC. Obviously, in the assemblies that we're talking about, you would need to use non-combustible fire blocking materials. The other fire blocking materials are for all the other places within the building that you would need fire blocking. Very importantly, what they've done is they have crossed out all other approved materials and added other materials approved by the commissioner. Now, this makes it a little bit more strict than the all other approved materials, typically the way that that was enforced. However, the Department of Buildings has assured me that this number 8 was put in there specifically because they know that they're going to need to look at other things like, when a steel fire block might be appropriate, or when an activated fire block might be appropriate, or some other innovation that that has come through. But important, it's important just to note that that right now the non-combustible materials on this list are your only option. This is the part of the presentation where we talk about some of those other topics around fire blocking. Now, there are a lot of them, and if you are working on a specific project, you should be going through and looking at what specifically applies to that project. But importantly, balconies and projections have their own requirements. Any balcony and projection will need to have a 3-foot distance of non-combustible materials completely surrounding that balcony in the adjacent elevation, and 12 feet above the walking surface. So 12 feet above walking surface, you can have no combustibles. It doesn't have the water resistant barrier exception. However, there's very few options if they're not going to use a combustible water resistant barrier. And so I imagine that this is just an oversight, and it will be enforced as a water resistant barrier being an exception. Another related change is that they've increased the requirements for the thermal barrier within your wall. So that means that you're now going to have to use something equivalent to 5/8 inch type X exterior sheathing rather than 1/2 inch. And that sheathing, exterior sheathing will need to withstand 20 minutes in an ASTM E119 rather than 15 minutes. Retrofits of unsprinklered buildings was another topic that went back and forth in terms of deliberation, and even from the proposed language to the final language, you'll notice there's very significant differences. So essentially, if you have an unsprinklered building that you are retrofitting and that is over 75 feet, you'll need to put up 3-foot bands of non-combustible material either above every opening or at a minimum of every 15 feet. So that's, I'm sorry, a maximum of every 15 feet. So that's what you're going to need to contend with if you're retrofitting unsprinklered buildings over 75 feet. HPL and MCM, there's a few other things to note. The first thing is that the 40-foot exception is essentially gone. You will need to have a NFPA 285 test for HPL and MCM down to grade now, and that means that your assembly needs to match your NFPA 285 test down to grade. Also, HPL and MCM will not be able to be used on the exterior of a CLT or SCL construction project. And again, you have some of those other requirements that we talked about before. Another good change to the code is that CLT is now permitted to be used. So if you're building with CLT or SCL, the reason why we're talking about it here is that you'll need to use non-combustible exterior wall coverings for those construction projects. So NFPA 285 will need to be run with fire blocks in place. So if your material needs or your wall assembly needs NFPA 285 to comply, then that NFPA 285 test must have fire blocking in place. You cannot just add fire blocking to an NFPA 285 tested assembly and be compliant. The question is about how we test that. The NFPA 285 test, as we reviewed in our little primer, has some of the most important measurement equipment at 10 feet above the window and 5 feet from either side of the window. So if you go 5 feet from either side of the window, that's creating a 10-foot span. And if you go 10 foot above the window, that then goes 10 by 10, and you have your 100 square foot compartments. Now, if we were to put those 100 square foot compartments or fire blocking in those 100 square foot compartments, essentially we would be covering all of the important cavity measurement equipment in the test and probably have a pretty good test, and that's not what New York City wants. So a big question is, how do we comply with this requirement and have a reliable test? It's not clear yet, but I know that New York City, the Department of Buildings, knows that this is an issue that needs to be resolved in some way. The addition of fire blocking and some of these other requirements has also come with a special inspection that is now for NFPA 285 assemblies and fire blocked assemblies to make sure that that fire blocking not only is in there, but it meets the design in both the test and the design criteria. You see that it says they've added language that says component properties, thicknesses, orientation, cavity sizes, and location of thermal barriers, fire blocking, and cavity closures. They also have said manufacturer's installation instructions and NFPA 285 tested assembly design documentation. That means that you're going to have your NFPA 285 tests or something test reports or something very close to it, and installation instructions that reflect that as part of what's being inspected here. So this is the last code language that we're going to review today, and I think some of the most interesting added language that New York City chose to put in here. This language is about the registered design professional and what they have to certify. There's very specific language, very specific wording that has to be in the submittal from the registered design professional, and that language is: any deviation which occurs during the course of installation will be evaluated and approved by the applicant of record or registered design professional. No deviation shall be approved that would result in an assembly that would otherwise fail to pass the acceptance criteria of NFPA 285. Very interesting language, putting the architect on the hook not only for the what is done on site, but also for whether that what is done on site will pass NFPA 285. I can tell you from my experience that this is a very difficult thing to certify. I am very curious to see how the Department of Buildings and architects in New York City respond to this language, but there it is. So I know this was supposed to be a no judgment zone, but I figured I would end on the thoughts I had on some of this language. You've heard some of it peppered throughout, and I've tried to be as no judgment as possible following rule number 2. But yeah, I think this is going to make it a little more difficult to achieve high performance building enclosures. We're all going to have to work a little harder to find innovative ways to meet competing goals, right? So in New York City, we have local law 97, and that's going to be harder to achieve, especially if we have to put any sort of continuous breaks or continuous bridges in the into the insulation layer in order to achieve that. Obviously, the increased interruptions in the wall covering and any other additional penetrations that we're going to have to create are going to create more paths for air leakage and water ingress into the walls that we don't want. And just the general implication and confusion around the current language, I think could potentially have some negative effects on our designers, contractors, and the building performance for New York City in general. Obviously, I think New York City could have and should have done better in terms of the fire blocking requirements. I think that distracted a lot of focus that could have been better used for uh, compliance requirements that would have made better buildings. But I also think there are a lot of good things in this code and some things that the rest of the country or the rest of the jurisdictions in this country should look to follow in some way. And that essentially revolves around the increased focus and scrutiny on compliance documentation. I think that's something that is needed around the country. And as long as we make sure that designs match testing and buildings match those designs, then we can build better buildings in New York City. So that concludes the presentation for today. I know it says Q&A up top, but please feel free to send me an email if you do have any comments or questions about some of the things that I said. If it has to do with some of the confusion in the code language, there's not a lot that I can do to help you there, unfortunately. I have had to respond to many people saying that we're just going to have to wait to see what the Department of Building says for some of those gaps and confusion that we addressed here today, and some things that I'm sure you'll find as you're going through it. Again, my name is Steve Gaynor, and thank you for listening.